Hi everyone, this is Dr. Kiranmayee, working as professor in the Department of CSC and also looking after the technical trainings at VNR VJYT. So today I'm going to deliver a lecture on Introduction to Data Structures. So first we'll discuss about what is data. So data, when you say, it can be a collection of facts and values. Means, suppose example, if you take it, the student names in a class. Suppose you say AA, BB and XX. So this is a collection of names and it does not have any meaning to it. It is not going to produce any meaning to it. It is nothing but you can call it as data. And suppose if you take marks of a student, suppose you say 70, 60, 50. So this, we say this is the data, but it will not create any meaningful data. Temperature, we say 70 degrees centigrade or else 14 Fahrenheit. So this is also a collection of which data? Temperature data, right? So data on the whole, we say it is nothing but the collection of items, things, values, facts, figures, which does not give any meaning to it. Then we move on to what is called as information. So in the previous slide, we have discussed about data. So data, what you have said, we said that it is a collection of things which is not meaningful. But what is information? Information is nothing but the data is being processed. When the data is processed, that is called as an information. So this information will be having the meaning to it. So when you process the data, when it has some meaning to it, it is called as information. Suppose marks, if you take it, marks of a particular student in 6 subjects, if you take it, 60, 70, 80, suppose 50, 55 and 65. Right? So with this particular data, when you want to process it, you can generate the percentage, right? When you process it, you can generate the percentage. Means what? The processing of this particular data, you're going to get the information. That is nothing but you can calculate the percentage of a student. And after calculating the percent of the student, you can even generate the result. That is, what is his particular, whether he belongs to first division or he belongs to the second division or else third division, etc. So now we conclude saying that data is nothing but the collection of things and facts. But coming to the information, when the data is processed and it has some meaning to it, then we call it as the information. So these are the basic building blocks for the data structure. Then we move on to what is called as data structure. So before going to the definition of a data structure, suppose, imagine that you have in your house a particular set of, in your house, take your house, okay, and also consider clothes. So every day we are going to have the clothes in the washing machine. Later on we are going to have a ladder and we are going to dry it. And after that, all these particular clothes, if they are lying on the bed, okay, what happens? This particular whatever the data is there is lying on the bed. We are not storing it anywhere, right? But actual thing is, when these clothes are folded and stored in a particular cupboard and also in a particular one by one class, isn't it? So it is very easy for the particular ourselves to pick up the cloth very easily. And suppose another example you take it is a library. The books in the library, if it are lying on the table without storing on a particular shelf, isn't it? So whenever you visit a library in our particular engineering college or any other college, so we see that the books are arranged in a shelf, discipline wise, isn't it? Department wise, branch wise and also course wise, these books are arranged in the shelves. So what I am going to say is, here the first thing is you are storing, right? You are storing these particular things or whatever the items very efficiently. And why you are storing on the shelf or else on a particular cupboard, very arranged. Why you're arranging it means what? Arranging the particular items on the shelf, it means that you want to access it very fastly. Okay, whenever I want a particular book in a library, what we do, we directly go to that particular shelf, course-wise arrange, and we pick up the book. Means what? Very easily you can pick up that particular book. So now we define what is data structure. So data structure is a way of, right, organizing, right? Organizing in the self, arranging, storing in the means saving this particular data in your system. Managing means what? You're going to manage the data in such a way that you can access it very efficiently. So think about your particular home. Your home is nothing but your CPU, right? In your home, you're going to store many things, right? Large volumes of things can be stored in a home. Similarly, in CPU also, large volumes of data, you can store it very, very efficiently such that whenever we want it, we can access very easily and efficiently. Suppose imagine that your particular library, the books in the library are not arranged on the shelf, they are lying on the table. So can you access the book whatever you want it? No, right? Suppose they are arranged on the shelf in a particular manner, or according to the discipline or else course-wise, then very easy for a particular student or a particular staff to pick up a book. So I conclude saying that your data structure, what is a data structure? How you're going to define it is nothing but the organizing, storing and managing the data so that you can access it very, very efficiently. Now, why do we need these data structures? We need the data structure for various reasons. The first one is what? To store the large volumes of data, right? So simply if you take a particular, suppose you take a normal primitive data type, whatever you can say, suppose an integer, is it not? An integer, only it allocates, right, 4 bytes. In these 4 bytes, you cannot store a particular large value or large amount of data. So, using a particular data structure, you can store the large volumes of data. Suppose you take any dynamic data structure, you take it, you can store large volumes of data. Access data very quickly. That is, suppose you are going to go to the supermarket, right? Take an example of supermarket, right? So, in the supermarket, how the particular things are arranged, right? We know all the particular dairy items will be placed over here, right? And then whenever you want a particular, suppose a milk packet or else a bread packet, directly we go to that particular the product and we'll pick it up. Means what? The supermarket, the officials will arrange the things in such a way that the user can access very, very easily or quickly. So that is the need of a data structure. Now insert and the data or delete the data very easily. Suppose if you take a data structure like linked list, right? In this linked list, very easy for a particular person to either insert an element into a linked list or delete an element from a linked list in a very less time. You can delete or insert whatever you want to do it. You can do it very, very efficiently. And reduce the memory usage. Reduce the memory usage means in data structure, we are preferring most of the cases the dynamic data structures we are going to use it. In dynamic data structures like linked list, okay, memory will be saved. Means we are not going to waste any of the particular memory. We can reduce the memory. Improve the program performance. If we use the data structure, the performance of the program will be improved. Means the time complexity required to execute the program will be reduced. The best example is searching a number. If at all, here the elements are arranged in the sorted order. Suppose in the unsorted order, suppose 70, 50, 40, 80 and 90. I want to search whether a particular element is present or not. Suppose I want to check whether 95 is present or not. Means what? You have to apply which searching technique? Linear search we have to apply. Linear search, when you apply on this particular array of elements, it takes more time to search whether an element is present or not. Suppose the same list, if you are going to keep it in a sorted order, like 40, 50, 70, 80, 90. Then what? To find an element, whether it is present or not, we apply binary search. So when you apply the binary search, the time complexity got reduced. A linear search, it takes worst case, takes O of n. And whereas in binary search, the time complexity to search an element will be O of log n. So these are the various reasons why we need a data structure. Then we move on to the classification of data structure. So the data structure have been broadly classified into primitive and non-primitive data structure. So coming to the primitive data structure, int, you have int, char, boolean, float and pointer. All these primitive data structures are the basic building blocks. Means what? Suppose you have to build a house. What is the basic building block? Is nothing but you want the bricks, isn't it? Without bricks, you cannot build a house, right? So here, all these primitive data structures are useful or the basic building blocks for this particular data structure, and all these are used to store only the single value, right? So if you take int, it can store only integer value, single value will be stored. Character, single char only. Suppose x will be stored in a char. Boolean means whether it is yes or no, only one of the value. Float, decimal values will be stored in float. And coming to the pointer, you know already that pointer is nothing but a variable. We store the address of the another variable. So now coming to the non-primitive data structure, these primitive data structure are used to build the non-primitive data structure. So coming to the non-primitive data structure, these have been classified into linear data structure and non-linear data structure. So first we discuss about the non-linear linear data structure. So coming to the linear data structure, we see linear data structure is defined as the data structure which is where the elements are arranged in a sequence, right? In case of a linear data structure, how the elements are arranged? Elements are arranged in a sequence, right? When coming to the non-linear data structure, in the case of non-linear data structure, elements are not arranged in a sequence. Here, the data will be connected to the multiple other data, right? So this is coming to the non-linear data structure. So under the linear data structure, we have again static and also dynamic data structure. Under the static, we have an array, right? So you know that what is an array? Array is defined as the sequence of elements stored under a single name and all the elements are of the similar data type, right? So all these elements are stored under a single name, suppose A, and you have an index 0, 1, 2, 3, 4, 5, 6, and here the elements you are storing over there in a sequence. Here, why you are saying array as a static dynamic data structure means here once the memory is allocated, if you say A of 10, right? Here the memory is allocated at compile time. Either you cannot either increase the size of the array or else decrease the size of the array once it is allocated. So if I want to insert an element into an array, then entire array has to be shifted rightwards. And if you want to delete an element, suppose 8 I want to delete it, then entire array should be moved to the left side. So it is a very costly operation in case of an array. So the insertions and deletions operations in an array is very, very difficult. For that case, we are going for a dynamic data structure. So in case of a dynamic data structure, we have the first one, you have a linked list. The first one is linked list. The second one is stack. And third one is queue. So first we see why we are going for the linked list. Because just now we have discussed that we discussed that array, what is the main disadvantage of an array is what? Memory is allocated at compile time. So here either you cannot increase the size of an array or else you cannot decrease the size of an array. For that case, we are going for a dynamic data structure, and first one is called linked list and the second one stack and the third one queue. So what is a linked list? So suppose I'll give a real life example. You take a train, right? So what is the train? You have several bogies connected, right? Several bogies will be connected and the last bogie you have a cross symbol over there. This identifies that, what is this identifies? That is the last bogie of the train. Now, during the festival season, suppose the festival arises like Pongal, right? When the Pongal arrives, so most of the people wants to visit their villages. Then a lot of crowd wants to visit the villages. At that time, what the department will do, the railway department wants to add the bogies to it. Right? Bogies, it has to be added. So how the bogies will be added to this particular train? Okay, you can add the bogies very easily. At the beginning directly, you can add it, or at the end you can add it, or else at the middle also, right? Only thing is what? Just they have to add the connections, that's all, right? Very easily the bogies will be added. And similarly, suppose festival is over. Now, I want to just, the bogies I want to take it out and a normal train I want to introduce it. Then what the railway department will do again? They'll delete it, okay? Very easily they can delete the first bogie, the last bogie, whatever they have invented, and also the middle bogie also. Means what? Very easily, what I want to say is, you can perform the insertions and deletions operations very easily in case of a linked list. Okay, the best real life example is nothing but is a train. Okay, so how a linked list will be in our computer science? Here is, you have the linked list will be represented like this. Okay. So, what is a linked list? It is a sequence of nodes, right? It is a sequence of nodes where it contains two parts. The first one is the data part, 10, 20, 30, 40. Suppose this is the data. Then each node contains the address, suppose 100, 200, 300 and 400. And I said the last node will be a null is stored to represent that is the end of the linked list. Now, what is the second part? The first part is the data. The second part is store the address of the next node. So here, the address of the second node will be available in the first node. And similarly, the address of the third node will be available over here. Similarly, the address of the last node will be available over here. Right? So, sequence of nodes you are connecting here, whereas the first, each node contains two parts. The first one is the data part, the second one is the address part. Here, it looks similarly like a train where very easily you can perform the insertions and deletions operation. Only thing is, suppose I want to delete this one, only thing you need to change the link like this, right? And if you want to add in any particular node, suppose at the end, if I want to add it, right? Simply, if this address is 500, this 500 will be replaced over here. This link will be established and this will be null. Okay. So this is only the basic introduction. So in detail, performing all these operations and writing the functions for these all operations, we'll see in the later videos. This is about the linked list. Then coming to the stack. So stack is also a linear data structure. Okay. So what is a stack is? Stack is a linear data structure which has only one end called as a top. Okay. So before going for what is a stack, I'll give a real life example. The real life example is, suppose in all your houses, you'll be having the idli plates, right? How the idli plates will be there? You have a stand over here and the plates will be arranged like this, right? So you can insert the elements only from the top. Okay, you cannot insert from here, right? And also you take the bangles. Okay, the next example is the bangles worn by a woman. Okay, so you can insert from this particular end, right? And when you want to remove from this particular hand only, right? So similarly, what is a stack is? Stack is a linear data structure which has only one end called as a top, and this top is only used for what? For insertion, and the same top will be also used for the deletion. This is about the stack. Now, coming to the queue. Okay, what is a queue? Queue is a linear data structure. Okay, so suppose I again give a real life example for a particular queue. So what is the real life example is? Suppose you go for a movie. In the olden days, isn't it? You have a counter, right? So you have a counter over there and all of us will be standing in a line. Okay, so how many ends it has? It has two ends. One end you are entering and the other end you are going to deleting. So the queue has two ends called as the rear. One end is called as the rear and other end is called as a front. So the rear end is used for what? Only for insertion of an element to this data structure. And what is the front? Front is utilized for what? To delete the elements from a queue. So what is the difference between a stack and a queue is? Stack has only one end called as the top, and same end will be used for both insertion and deletion. And for this insertion in the stack is called as a push operation. And whereas the deletion operation in a stack is called as a pop. So we use a standard terms like top, push, pop in case of a stack. Whereas in case of a queue, we say that front and rear. Rear will be used for what? Inserting an element. Front is used for what? Deleting an element. Okay. So now the other example also, suppose we visit a library, isn't it? When we visit a library also, we form a queue, right? The librarian is going to give the tokens at one end. The other end, the particular student will be adding it, right? So like that, you can map various real life examples in your career. Now coming to the non-linear data structure. So non-linear data structure, I told you, it is the data is not in a sequence, whereas in the case of a linear data structure, the data is arranged in a sequence. But whereas in case of a non-linear data structure, the data is not arranged in a sequence. So here, suppose one of the nonlinear data structure is tree. So what is tree here? Tree is containing the nodes, okay, containing the nodes and also edges, okay, such that it has a hierarchical structure in it. Hierarchical structure means take your family tree, you say, isn't it? Family tree, what does you have a family tree? First, you have a grandfather, okay, and grandmother, right? And here you're going to, isn't it, the ancestors, you can call these as an ancestor. Then you say, isn't it, for its children, right? Then its children. Hierarchy. So the family tree is the best example of a real life example for a tree. So tree contains the nodes and edges such that it forms a hierarchical structure. And mainly this tree is used for searching operation. Okay, efficiently it can search whether a particular element is present or not in O of log n time, right? And coming to the graph, okay, graph is also a nonlinear data structure where it contains the vertices and edges, and only difference between the tree and a graph is the graph contains cycles, whereas the tree does not contains any cycles. Okay, so where the graphs are used is, the best example is here you're using the Google Maps, right? Google Maps, I want to search or I want to move from one location to the other location. So it is going to provide as a path. What path? Shortest path. Okay. So graph is a nonlinear data structure which contains the vertices like A, B, C, D and contains the edges. So these are called as the edges E1, E2, E3 and E4. Okay. Such that it may contain cycle, it may not contain cycle. Whereas tree does not contains any cycle, right? So the main advantage of graph is to find the shortest path, right? So this is about the today's lecture on introduction to data structure. So next lecture continues with the stack. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.